Welcome to my Raspberry Pi RP2040 project part number 4, integrating a 3-axis accelerometer. This is Ron from emicros.com. In this session, I'm developing the software for the NXP Semicon MMA8451QR1 3-axis 14 or 8-bit digital accelerometer into my Raspberry Pi RP2040 module. Be sure to hit the like button and leave a comment below. Here's the schematic. For the MMA8451Q, we have the I2C lines connected, as well as interrupt 1. And now for the software. I'm using the Arduino IDE with the Raspberry Pi RP2040 extension. The source code for the following code is available at www.emicros.com. If you need the Arduino IDE with the RP2040 extensions, I refer you to Part 2A in this series. Open up a new Arduino sketch and include the wire.h header file. The I/O pins are set next. The I2C data signal is on GPIO 0 and the SCL clock signal is on GPIO 1. The LED is on pin 18, interrupt 1 is on pin 2, and the I2C address for the MMA8451Q is set to 0x1C. Control registers for the MMA8451Q as well as initialization values are defined as well. Now we define the variables. The last variable x, y, and z are used to calculate a delta. The A array, which has 6 elements, is used to read the acceleration data as 8-bit values, and AX, AY, and AZ are used for showing the raw acceleration or for calculating the deltas. Two functions are shown here to set or read the MMA8451Q registers. Here's the setup function. The pin loads are set first, followed by initializing the serial port. The I2C is set, and then the MMA8451Q registers are initialized. Note that the data rate is set to 80 milliseconds, i.e. that's when a new reading is available. And finally, here's the main loop function. When the INT1 pin is low, indicating new acceleration data is available, the acceleration registers are read. The raw acceleration data is calculated and sent out via the serial channel. Notice that if only the change in acceleration is needed, the last x, y, and z variables should be uncommented. Here's the serial plotter, which is included with the Arduino IDE, showing the x, y, and z acceleration data as I move the RP2040 module around. That's all for this episode. This is Ron from emicros.com. Be sure to hit the like button and leave a comment. See you next time.